Welcome to the Stormsurf video surf forecast for the week starting Sunday, March 10th. Looking at significant wave heights for the North Pacific Ocean, we see a gale with seas at 36 feet pushing through the northwestern Gulf of Alaska. This is the second in a series that have produced decent seas, aimed well east, and swell from the first one, in fact, is hitting California now and continued to are expected to continue through the next day or two, with this second swell arriving right behind it. So a run of actual surf is in the forecast. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a dip in the jet. We sort of see one right there, and that dip, if it is real, would help support a counterclockwise flow aloft and down at the surface. And counterclockwise flow in the northern hemisphere is a sign of low pressure, and low pressure, of course, if it's strong enough, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, produces surf. We also have a backdoor trough here, right off of California. That's creating a small circulation, driving south winds along the coast of central California and offshore winds north of it, off of northern California at the moment. And that trough, I believe, is expected to continue falling south. So right now we have kind of a mixed flow. Basically, the jet's semi-consolidated, pushing off Japan, and then it starts to split right on the dateline, just as it has since maybe the first or second week in January, somewhere in there. Just this persistent split pattern. Between the split, there's the northern branch, there's the southern branch. Between those branches, you get high pressure, and high pressure does nothing for generating surf. The interesting part, at least for today, is there's a bit of a backdoor trough, as we mentioned, off the California coast, but by and large, we've been in this split flow for a long time. The good news is we think it's about to change. Finally, now that winter's almost over, we're going to get into a favorable pattern. Just maybe. Anyway, all right, so we go into Monday. Notice the first signs of the change in the pattern developing. Winds building 1, 2, 3, 4. What's that? That's 170 knots off Japan, a bit of a trough over the Kuril Islands, but just kind of this muddled pattern. There's that cutoff low again off of the Southern California coast as we get into Monday night. We'll just sort of roll through this. Notice bit of a trough here persisting in the northwestern Gulf of Alaska Tuesday night into Wednesday. Here we go into Wednesday. Winds up to 190 knots pushing off Japan. Hey, it actually looks halfway decent. The jet consolidated, pushing the whole way over the dateline and beyond. Still a bit of a split right here. You see northern branch, southern branch. But let's see what happens as we get a little bit further out. Look at that. The split disappears. This is actually a decent looking jet stream. Again, 190 knot winds consolidated, pushing into the western Gulf of Alaska on Thursday. And here we go. A trough starts to dig out right here. And look at that. The split now moves to about 140 west. That's 900 miles off the California coast. The entire North Pacific theoretically becomes open for business. All we need is this trough to develop, and that's exactly what's supposed to happen as we get into Saturday. So we're a week out, but developing trough in the Gulf of Alaska, being supported by 170 knot winds feeding it, and continuing into Sunday. This actually looks like a decent pattern. Late. Notice the split over California. That supports high pressure there, probably an offshore flow. Couldn't be a much better setup. And the assumption is, and the trough continues in the Gulf of Alaska, some sort of gale development in this region looks likely. And probably more behind it, assuming the jet holds together. All right, let's go take a look down at the surface, see what it tells us. Here we are, surface level pressure, surface level winds. The gale, the second in the series, is in the extreme northwestern Gulf of Alaska winds, 35 to 40 knots, almost aimed northeast. A little bit of energy, probably going to radiate south into maybe central California. The split jet right over in this area, there's high pressure. Actually, it's a double barrel high, 1028 there and a 1028 millibar high here. That does nothing. That just pushes the storm track up into the Bering Sea, and that's basically what we have going on. And you also, with this high, you get stronger than normal trades pushing over the Hawaiian Islands. You can see that there, 20 knot winds. Roll this out. Another little low trying to organize in the Western Gulf on Monday. Another one off Japan. Let's see if any of these, see, they just don't do anything because the jet's still split. Yeah, you got 30 knot winds, but that's just not enough. See the yellow 30 knots there. Not strong enough. And we continue on. We're waiting for the jet. There we go. When the jet finally starts organizing into Thursday, we got 2 low pressure systems here. Let's see if they do anything. Here we go. 35 knot winds. That's not nothing particularly strong at all. Maybe good for 13-second period swell. But it's a start north of Hawaii, aimed decently at the islands, the U.S. West Coast. Here comes the high pressure setting up over California. It'll probably ridge inland another frame or two down here. Second low developing in the western Pacific on Thursday. We get into Friday, and you see, here we go, decent gale, 35 knot winds, targeting Hawaii and the U.S. West Coast. Another one building over Japan. The storm pattern starts building. Just a nice persistent flow with, notice this, it is westerly winds into the Hawaiian Islands. This says next weekend, Saturday night. Another gale developing off Japan, 45 knot winds. You get the general pattern here. We get into Sunday. There we go. Good setup for swell development for California. Offshore flow, high pressure inland setting up over the Great Basin. Another gale developing over the dateline. So 1, 2, my guess is this one will amplify as it falls into the trough as well. And theoretically, we're off and running in a decent swell producing pattern. Finally, after 2 months of just nothing. So here we go. Let's go take a look at the effect of those winds on the ocean surface. We're actually going back in time to Tuesday of last week. Gale developed pushing off Japan. Remember, the jets split right around here, so it pushes the storms off to the north. But we got, what is that, 37-foot seas, 40-foot seas, 43-foot seas, 44-foot seas on Wednesday night. This is what created the swell that's just starting to hit California now. Period in the 19-second range. There's maybe 20 seconds this morning up in Northern California. Period will drop down to maybe 18 seconds by later this afternoon. Some decently rideable swell should result if the local winds would cooperate. Anyway, that gale pushed off into the northwestern Gulf and faded on Friday. You see it. Another gale developed Friday night, again with 40-foot seas following a similar track. Seas building to 43 as we get into Saturday, 42.5 feet, something like that. You can read the numbers. You see it faded out, and this is today's image this morning, 12Z Sunday, fading with 30, 32, 34, 35-foot seas. I think we said 36 earlier. 35-foot seas in the northwestern Gulf. So swell number 2 on the way behind swell number 1 that's hitting right now. All right, let's go look into the forecast now. All right, so as we get into Sunday evening, that gale as well fades out. Seas still, broad area of 22-foot seas even into Monday, fading out. Remember, a couple of little gales try to organize, not doing much. 20-foot seas, yeah, it's good for maybe background swell, we'll call it, into Hawaii and the U.S. West Coast, but nothing much. It's really, as we get into Thursday, the first gale starts forming with 26-foot seas north of Hawaii. Doesn't really get organized, small. Broader area of 24-foot seas. Behind that, pushing over the dateline, building up to 28 feet on Friday night into Saturday, continuing to gurgle 30-foot seas into Saturday night. The second system builds off Japan with, 39-foot seas as we get into Sunday. And here we are at 180 hours out. That would be a swell. That would be a swell. Both targeting Hawaii and the U.S. West Coast. And theoretically, the machine should ramp up from there. Let's take a look at local winds. What's going on right now? Sunday. This is actually Sunday morning. High pressure, 1030 millibars. Actually, it said 1028 on the lower res model. Here's a higher res version. That is driving clockwise flow around high pressure. Driving east winds, trades hard over the Hawaiian Islands, 20 knots. Little cutoff flow. Remember that backdoor trough off of California. Little tiny low pressure was like a 10 millibar low, hardly even a low. But it's generating south winds up the counterclockwise flow around low pressure. So south winds, but then north of the low, the flow will turned offshore, and we'll just sort of put this in motion. We go to Monday or Sunday at about 5 p.m. daylight savings time now, and that should start driving an offshore flow into, we'll say, the San Francisco Bay Area, maybe down to Monterey Bay by sunset, something like that. Trades continue for Hawaii. All right, so we go into Monday. What's going on? Light flow early, trades for the Hawaiian Islands, and then high pressure. You see it building, north wind starting to build by Monday night into Tuesday relative to California. Notice as the high moves east, the trades start slackening for the Hawaiian Islands. We're down to 15-knot trades. While winds, we'll call them trades, they're really north winds, northwest winds for California trades, 20 knots as we get into Tuesday, and into Wednesday or Tuesday night, 30 knots, trades light for the Hawaiian Islands. Then the high pressure should start to move onshore here pretty soon. You see, again, still a 15 to 20 knot flow for California Wednesday night. Trades getting progressively lighter for Hawaii. Into Thursday, probably a light offshore flow near shore for California. Light winds, 5-10 knot easterly trades for Hawaii. But notice here comes the first low pressure. You see wind starting to turn south somewhere right around there. Let's see if that, nope, doesn't make it into Hawaii. Still trades. So we get into Thursday night and Friday. Light offshore to north winds for California for Friday. And let's see, Saturday, there's high pressure holding. It looks north winds over outer waters, but be willing to bet that's probably northeast winds near shore. Now here comes probably the change in winds for Hawaii. Let's see. And there you go. There comes a front probably right along in there. And northwest winds start for the Hawaiian Islands on Saturday night, where we get the offshore flow for California. And here you go. Look at this. The Gulf finally wakes up, full of low pressure. Fetch, aimed both at Hawaii and the U.S. West Coast. Unfortunately, Hawaii gets a weather impact. California isolated for the moment, as long as the jet stays split over California. All right, let's go take a look at precipitation. And we're focusing mainly on California here. This is Sunday, 18C. Yeah, there's here in Central California, Northern California, yeah, scattered showers. That's about right. Scattered snow showers for the Sierra, maybe building a little bit in the evening. That all clears out on Monday. High pressure. You see the isobars taking over. Little push of precip into Northern California as we get into Tuesday, but not much, and it's gone. A dusting of snow probably for Tahoe. And then after that, high pressure, split jet stream. Literally no precip for California. Things significantly start drying out. We'll get more into what's driving all this in a minute. So the really good news is we spent some time this week. We got literally all the weather models up and running, every one of them as of this morning. So you should be able to go access data the way it used to be. It took a while. Sorry for the inconvenience, but we finally got it all up and running. So we're looking at snow mainly here for the Sierra. You can see Sunday into Monday, that all fades out. And then maybe a dusting as we get into to Wednesday morning, and then it's all gone, and then high pressure starts setting up. This is the long-running GFS. It goes out 240 hours. Yeah, maybe a dusting, a little bit of rain, if anything, at 240 hours out. But basically, we're heading into a dry pattern for California. And with that, we can look at snowfall, projected snowfall accumulations for Squaw Valley. You can see we're talking, 2 inches or something like that. You can actually click on these images, and here you go. You get the actual readout. Okay, 1.5 inches. Sorry about that. Okay. Snowfall, snow level. So this is the bottom of Squaw, the solid line. The blue line is the top of Squaw. Where it's red, that's liquid precipitation, if there is any precipitation. But you can see the general pattern is warming, and we're talking like spring-like conditions for the Sierra starting about the 13th of March and continuing on after that, associated with high pressure in control. Wind, a little bit of wind, probably associated with the last little push of a storm, and then light winds, all symptoms of high pressure in control. Looking at the Mammoth dashboard, basically the same thing, a trace of snow and then nothing. Same deal with temperatures, but by virtue of Mammoth being higher, with the base at 8,000 feet and the summit up at about 11,000 feet, you can see not as warm, but still pretty warm. If there were precipitation above freezing temperatures, day and night after you get into about March 15th. Spring ski conditions, maybe not so horrible. And the same deal, a push of wind, and then things settle down. All right, so the million-dollar question, what's going on with the macro level picture? What is causing the jet to change? And what's causing the chat pattern change? And is there anything going on with El Nino? So we go through our usual drill. First, we like to inspect winds on the equator in the West Pacific. So this is the East Pacific here. This is the West Pacific there. That's New Guinea. There is the equator, 0 degrees. And at 180 degrees, that is the international date line. The arrows are what we're looking at. These are sensors from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino, but also gives us a good sense of what's going on with Madden-Julian oscillation. The MJO, when in the active state, and the MJO moves from west to east the whole way around the planet. When the active phase is here, it tends to suppress trade winds, if not reversing them if the active phase is strong enough. And if you get a series of strong active phases in a row, often that can be the start of El Nino. So we always like watching here, one, not only because the active phase also feeds energy to the jet stream and in winter months helps support storm development when it's over in this region, but also the El Nino thing, also because it creates Kelvin waves, which are balls of warm water which travel under the ocean's surface and then erupt off of Ecuador, again also helping to fuel the start of El Nino. All right, so right now, winds, you just look at the arrows, trades east the whole way across the Pacific. No sign of the active phase of the MJO. If anything, this looks like the inactive phase because we have solid easterly winds over what we call the Kelvin wave generation area from 135 east to about 170 west, 5 degrees north and south of the equator. Just draw a box right in there. That's what we're mainly looking at. Now, we're looking at, but anomalies are what really counts, not the absolute wind speed. So winds, you see they're a little bit stronger from the east over here in the East Pacific. But when you get over in this region, they're pretty much normal. Again, no sign of the active phase of the MJO, but not necessarily a sign of the inactive phase either. What have winds been doing the past 5 days? Okay, same deal. These are 850 millibar wind anomalies, differences from normal for this time of year. There's New Guinea. Oh, there's South America, Central America, Australia, New Guinea, Philippines. Kelvin wave generation area from 170 west. Oh, there's the equator right there too. So draw a box in your mind right around in here. You see the blues and the arrows, easterly anomalies. That was on the 4th of March. And the same deal on the 5th, the 6th, the 7th, and the 8th. So that smells very much like the inactive phase of the MJO. Remember, we're looking for westerly anomalies, so you want to see yellows or oranges in the Kelvin wave generation area. We're not seeing it yet. All right, so here's the forecast, but it's also a hindcast too, back to February 8th in that area. Okay, and we'll go down here. So here it's the whole planet on one chart. The date line runs right up at 180, right through the middle of the chart. Kelvin wave generation area between these two tick marks going up. Now, let me draw your attention to, if you haven't seen it already, this massive red, white, whatever you want to call it, ball. That is a westerly wind burst, a significant active phase of the MJO, producing westerly anomalies blowing hard right in the heart of the Kelvin wave generation area from February 11th through about February 26 or 27. That certainly would produce a Kelvin wave. That is, these westerly winds in the West Pacific will take warm water there and push them to the east. Now, here we're getting closer. Here's today's date. You see the blues. Those are easterly anomalies, and that's a clear. So this would be the sign of a good sign of the active phase of the MJO, right in this area. Inactive phase of the MJO. The forecast? Hey, here we go. Westerly anomalies. Forecast starting today in the far West Pacific and building, almost filling the Kelvin wave generation area by March 17th. That's just a week from now. That's a good sign. But you know what? What that also means, that's likely what's driving the pattern change. The jet responds favorably to westerly anomalies in the far west Pacific. Now you go, well, why didn't it do it here? Why was the jet split all during February? Because there was other things going on as well. Very strong active phase of the MJO, but there was this El Nino thing, and we'll get into that in a little bit. But basically, we were moving towards El Nino, and then somewhere in early January, El Nino basically fell apart, and the El Nino forcing, or lack of forcing, the decline of El Nino basically overwhelmed the MJO. So these are waves within waves within waves in the atmosphere, and they all interact to create harmonics. And our suspicion is the failure or the demise of El Nino during this time frame overwhelmed the strength of the MJO and caused the jet to split. But part two is, and you'll see this in a minute, we think El Nino's rebuilding, and with the active phase of the MJO building, they line up, they force together, they amplify each other, and that is possibly what is causing the jet to now finally respond in kind. Another MJO model, this outgoing long-wave radiation, just another component of the MJO. Basically, the MJO is like low pressure, creates clouds. Okay, so the blues are negative anomalies. That means more cloudiness. The oranges, positive anomalies, less cloudy, more sunlight reflectivity off the ocean surface. So this is basically the inactive phase of the MJO. The Kelvin wave generation area, again, draw a box right there in your mind. There's New Guinea, again. There's the date line, South America, equator, you get it. Okay, so inactive phase of the MJO basically dissipates per the statistical model, let's say 5 days out, is gone. And look at the active phase. It moves from the maritime continent, these cluster of islands right here, to the west, fully in the Kelvin wave generation area, let's say day 8, and solid at day 15. Now the dynamic model, not so favorable. It says inactive phase holding completely steady. So this is really kind of weird, though, because this is a dynamic model. The GFS model that showed us the jet stream chart is a dynamic model, but they're sort of not talking in sync with one another. If the GFS model and the jet stream forecast says the jet is to be healing or consolidating, it seems highly unlikely that the inactive phase or positive anomalies, outgoing long wave radiation anomalies would be sitting here. It seems more likely they'd be moving off to the east. Phase diagram charts. Okay, another way of monitoring the MJO. Assume you're looking down on the north pole of our planet. The MJO moves from west to east around the planet, from the Indian Ocean over the maritime continent, over the West Pacific, over the date line, under the United States, remember, on the equator, across the Atlantic, and into North Africa, back to the Indian Ocean. The heavy dot is where the active phase is. The further away from the circle it is, the stronger it is. If the dot were way out here, it would be very strong. So we'll say a moderate active phase of the MJO is over the maritime continent right now. The statistic models say, two of them say it's just supposed to crash and like dissipate. One says it's supposed to move into the West Pacific 2 weeks out. The GEFS model says basically the same as these two statistical models, the active phase to crash and just sort of noodle around in the western maritime continent, not making it to the West Pacific. That is not hopeful. So we'll see who wins the battle here. The GEFS model with its consolidated jet stream, or whether really the jet won't consolidate, which is sort of what these guys suggest, and it'll just stay split. Upper level model, what this shows, okay, there's South America, Central America, New Guinea, Kelvin wave generation area right in there. Where the greens are, areas favorable for precipitation. One would say the active phase of the MJO, and one would also assume a consolidated jet stream. Active phase of the MJO pushing off to the east from now through and moving out of the Pacific on April 4th, followed by the inactive phase, pretty healthy version of the inactive phase from April, end of March, making it the whole way across the Pacific through April 19th, followed by a weak active phase of the MJO. 2 more models to go. All right, CFS model, 850 millibar wind anomalies, same deal. Kelvin wave generation area between these two tick marks. You can see here is our one. Here is the massive westerly wind burst that occurred in February. associated with the active phase of the MJO, the solid contour, and tropical storm formation in the West Pacific during that time as well. Here is our dotted contour, the inactive phase of the MJO. The blues are easterly anomalies you see, not completely taking over. But here is the forecast building active phase of the MJO, already getting a little toehold in the West Pacific. Here's our next westerly, we'll say, I don't know if I call it a westerly wind burst, but bout of westerly winds. The good news is here, look at this. In the Kelvin wave generation area, right in between about here and here, westerly anomalies forecast pretty much nonstop starting tomorrow through the entire rest of the month. This is a good sign. We talk about potentially El Nino redeveloping. This is what you'd want to see. And then finally, the long-range CFS model. So this is past history down here. This is future forecast here. This is our Kelvin wave generation area between these two tick marks going up. This is our big westerly wind burst that occurred in February. And you can see, here we are today. Give that, what, maybe 3 days. Westerly anomalies start building in the Kelvin wave generation area, and they just build and build and build, and they don't stop through June with an embedded westerly wind burst. Pretty solid. I mean, even little hints of it non-stop, but this looks very favorable. When we say that we think El Nino is redeveloping, well, we'll talk about that in about 1 second. Let's overlay the MJO. So here's our inactive MJO that's going on right now, the dotted contour, and it's going to continue into mid-March or so. But even with that, westerly anomalies are supposed to start building as the active phase starts pushing from the west into the Kelvin wave generation area. You see that. Now, you also notice, as we get further up here, the MJO starts looking much weaker. This is actually, it looks stronger in this run of the model, but the past week it's been very ill-defined, but with massive, solid westerly wind anomalies. This looks like a full-on westerly wind burst scheduled from, mid-April into the end of May. That would be a long westerly wind burst if it were to occur. All right, let's overlay the low pass filter. This is what really tells the story. So this is the area bias towards low pressure, we'll call it. And this is back in November, December, right about when we got to Christmas. See, there's 1, 2, 3 contours. This is what was building towards El Nino, and all of a sudden, the third contour just dropped out. And the MJO got stronger as compared to here, more contours, stronger MJO signal. Then notice, so this is when we say that we thought that like El Nino started falling apart, and this is when the jet split pretty much. It actually split a little bit delayed, like into here time frame. That's when the split occurred, and it's been split the whole way up to, and it's forecast to heal somewhere about here. We think, notice, 1, 2, 3 contours here, that El Nino might start getting a little bit of traction. And even as we get into May, now this is interesting, 1, 2, 3, 4 contours, a building El Nino. Actually, yesterday, this was down like somewhere in mid-April, the fourth contour appeared. So it's the model's wavering around, not sure, but its general trend is to say we think a building, some form of El Nino-ish pattern is to occur. And the healing of the jet stream, or the consolidation of the jet stream here in the, let's say, next week, if it happens, would be a sign, a push in that general direction. All right, let's start looking at El Nino and Kelvin wave signals. I mean, you can't have an El Nino without Kelvin waves. So the first way we do it, again, TAO buoy data, but this is subsurface data. East Pacific here, West Pacific here. There's 2 degrees north and south of the equator, across the Pacific Ocean only. These are the anchor lines on the TAO buoys. The X's are the actual sensors. That data is used along with a model to fill in the gaps to give you a profile of what subsurface water temperatures are. And we see 29-degree anomalies to the date line, roughly. The 28-degree isotherm actually making some westward progress here to 55 west. It's been holding around 160 to 165 for 2 months now, making eastward progress. And of course, the 24-degree isotherm pushing into Ecuador. You would not see that it would be like rising to the surface somewhere over here if we were in La Nina, but in a weak El Nino scenario, is about normal. But it's not the actual water temperatures that matter so much. It's the anomalies. Differences from normal from this time of year. And what do we see? Warm anomalies, 1 degree, basically covering the entire subsurface Pacific. They are flowing from this direction, this way, driven by these periodic westerly wind bursts that are occurring in the West Pacific that takes this warm water up here, right, starts pushing it to depth, and it forms a bubble just like that. 4 degrees centigrade above normal here in the central Pacific Ocean, where is that about 150 west, say due south of Hawaii on the equator, and it's pushing east, and at some point it's going to start gurgling to the surface. It's going to basically slam into Ecuador and go, I can't go anywhere. It's going to start gurgling up to the surface, creating a warm water slick there. It's going to get caught by the trades and start moving off to the west along the equator, back across the Pacific Ocean, and that is what changes the global atmospheric circulation. Actually, it starts changing because you have warm water on the surface that normally isn't there. Normally, there's upwelling cold water here. You know, that's what makes the fishing so great off of Peru. Well, you get warm water building here, and all of a sudden it starts raining off Peru, and that's how you get El Nino. But it takes more than one Kelvin wave. This is actually Kelvin wave number 3/4 of this cycle that started back in January last year. So we've been watching this. It takes 3.5 months for a Kelvin wave to make the trip across the Pacific. So solid Kelvin wave in flight right now. More details on that. The GODAS model imaging system saying it's even stronger than what the other one says. So let's count the 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5 to 6, there's actually dark brown, 6 degree anomalies. That is a very warm Kelvin wave, and it's not just that push. So this is really a combo. This is part of Kelvin wave number 3, I think it was, and Kelvin wave number 4. 2 westerly wind bursts that were almost back to back, moving a lot of warm water off to the east. This little pocket here, that's the upwelling phase of the Kelvin wave cycle from Kelvin wave number 2. It's about to get wiped out as this warm water pushes off to the east. Another validation of that model, this is sea level anomalies. So there's New Guinea, South America, Central America, Australia, you get it, equator, dateline there. And what do we have? This is JSON2 data. Strip off all the wave heights, strip off the wind waves, strip out the tides, and what do we see? A 10 centimeter bump on the ocean surface right there. 5 centimeter bump filling even a broader area, and a 0 to 5 centimeter bump basically covering the entire equatorial Pacific. And Hawaii's right there, and south of that, that's where that big bump is. So basically this says if you have warm water at depth, warm water expands, creates a bump on the ocean surface. This lines up very well with the previous 2 charts we looked at, and all it does is confirm that there is a large volume of pretty warm water pushing off to the east under the equator. So Kelvin wave number 3/4 is on the way. And here's the chronological overlay of Kelvin wave activity since April of 2018. Okay, and you got to kind of, here's West Pacific here, East Pacific here. That is the last little bits of La Nina. That's cool water in the East Pacific dissipating. Kelvin wave, generally, you can kind of see warm water. The oranges are warmer than normal temperatures, pushing off to the east from, I don't know, when was that? Maybe March into July, pushing into Ecuador. Kelvin wave number 1, upwelling phase of the Kelvin wave cycle. Kelvin wave number 2, much stronger, pushing basically from August, developed in August, reached Central America in December. Okay, upwelling phase of the Kelvin wave cycle. That's that cool pocket of warm water off Ecuador right now. Here is Kelvin wave number 3/4. See the aerial coverage of the dark reds here, and even the moderate reds as compared to this or this. Basically, it's a progressive Kelvin wave cycle. 1 weak, 2 moderate, 3, 4 stronger. And if one were to kick off an El Nino, this is exactly what you'd want to see. And typically a solid El Nino, you'll see good signs of it in the February-March timeframe in some form of a very strong westerly wind burst, active phase of the MJO, driving a large Kelvin wave off to the east. Now, to get an El Nino, you need probably 2 more of these during the coming summer and fall. But this is potentially a start. It's certainly a push in the right direction, better than La Nina, better than dead neutral nothingness. Warm water moving off to the east helps feed the jet stream, and that's what produces storms and surf. All right, surface temperature anomalies. All right, so this is interesting. So here's South America, Peru right there. Warm water off Peru. This persistent, so this is the fly in the ointment, this cool finger. One assumes there's like strong north winds blowing right in here, causing upwelling, drawing cool water to the surface. It could also be the last little bits of that upwelling phase of the Kelvin wave cycle running its way out. But we do see, here's the Galapagos, here's the equator, almost out to the dateline. Warm water, warmer than normal water, all in this area. The official Nino 1.2 region is from like 120 west from the equator, 5 degrees north and south, but actually kind of goes down in like that kind of thing. You see warmer than normal temperatures here. The official El Nino monitoring region is out here, 120 west out to like 175 degrees north and south, and you see warm water there. Now the thing is, these waters are not nearly as warm as they were a week ago. They seem to be cooling some. We're not sure what's driving that. We do know that there's easterly anomalies blowing here. We saw that earlier, so that's maybe causing a little upwelling, dampening the expression of warm water in this area. But out here, holding pretty much steady. And then you can see this is on out towards the dateline and the maritime continent. Seems like there's plenty of warm water, or warmer than normal water for this time of year in this region. If you got another westerly wind burst here, it could drive yet another Kelvin wave. Here's the temperature trend for just the past 7 days. Cooling, the blues, cooling from Ecuador out over the Galapagos. Again, associated with that finger of whatever's going on there. Maybe upwelling phase of the Kelvin wave cycle. And then modest warming at best in the El Nino-ish regions, but no clear signal one way or the other. Looking at the overall view, the reality is so the oranges and yellows are warmer than normal temperatures. If you get a good El Nino signal, it typically forms like a triangle in this area. You can almost make out something that almost resembles that now. All last year when we having these early forms of the Kelvin waves, they never really manifest on the surface quite as well as they are now. Still not super El Nino-ish looking, but definitely more than there was before. Also notice there's just a lot of warm temperatures over the entire global surface temperatures. Still, you can make out a bit of a signal here of maybe a tendency towards El Nino. But it's not the subsurface temperatures, it's not the Kelvin waves, it's not the westerly wind bursts or the MJO that is El Nino. It's got to manifest itself in the atmosphere. There's 2 indices for measuring the effects of, or what's going on in the atmosphere. This is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When the index, the daily contribution is negative, that means there's lower pressure over Tahiti. And look at this. It's been negative now pretty much nonstop for a month. It's actually 35 days or something like that, maybe even more. Down to minus 43 in mid-February. We're in the middle of that big active phase of the MJO and the westerly wind burst. Things mellowing out a little bit today. The 30-day average, minus 14.73. Pretty good sign. That is typically what you see when you have a healthy, robust active phase of the MJO. And we'll go back in time. See, it went from 0 in early February as the active phase built, and you just get stacking up negative anomalies. It pushes the 30-day average down to minus 14.73 today. But the 90-day average, running average, just a little bit below 0, minus 3.25. So this suggests active phase of the MJO. This suggests we're just going to go back in time here. We went from +2 to -3. Big deal. Basically dead neutral. Not really El Nino yet in the atmosphere. Here's the graph of the, this is what, the 30-day, this is the 90-day average here, slowly inching its way down from what? +2 to -3. Here is the 30-day running average. You see the active phase, the MJO. Now here's putting things in perspective, the 30-day moving SOI. Here's where we were in January. Here's where we are now in March. Significant drop, basically one, two active phases, the MJO, just driving the SOI negative. This looks good. I mean, and in historical perspective for the past 2 years, lowest it's been in 2 years. This was all sort of La Nina-ish territory, positive numbers. You can see the active phases, the MJO, followed by the inactive phases. They balanced each other out. Now we're in a deep active phase of the MJO. We're hoping we don't get some inactive phase that pushes us equally up as high. Probably not, would be our guess, but we'll see. It looks like we're trending in the right direction. And then finally, the ESPI index. Instead of difference in pressure between the area north of Darwin, Australia, and Tahiti, it's rainfall, total rainfall amount, satellite-based rainfall. The value today, 0.44, so just slightly above normal precipitation in this area here. If you have warm water in this area, warm water causes more evaporation. Evaporation causes more precipitation. And so this suggests, yeah, there is warmer water down here on the equator. You can actually see it here. Here's precipitation. This is what? The rainfall anomalies for the last 30 days. A little bit more than normal, but not markedly so. But at least we're not in the negative anomalies where we have been for 2 years during La Nina. This suggests that finally La Nina is dead even in the atmosphere. We're at a normal pattern, maybe trending weakly towards El Nino. That's a good sign. And then finally, the CFS version 2 forecast for Nino 3.4 sea surface temperature anomalies. That's the official El Nino monitoring region. You can see we had negative anomalies back in April 2018. That was La Nina. We sort of moved neutral all last year, July, October, maybe inching up temperatures 3/4 of a degree above normal, and if you go for 5 months like that above half a degree, you can declare El Nino, though there's really been no atmospheric component to it, but NOAA declared it nonetheless. Here we are today, the forecast. Now this is, we're just going to say it's hard to swallow. Don't believe it for a second, but we're grasping at straws. We'll take anything we can get. The forecast says sea surface temperatures to continue to build up to 1.5 degrees as we get into the summer, and maybe 1.6 degrees above normal into the fall. But this model was saying, it was something like 1.25 or something all the way through fall into winter, and we eked out about half of that. So let's assume next winter we get half of this. We'll be at 0.8 or something. We'll be noodling somewhere right around here, which would be, again, this continuation of this just very weak, minimal El Nino-ish kind of pattern. But still, that's better than La Nina. It still feeds the jet stream, still feeds the storm track, and if nothing else, gives us precipitation. We did quite well in California. We're up at Northern California is 170% of normal or something like that. So not so bad. So to wrap things up, short term, the jet stream is forecast to consolidate by the end of the week. Midweek and let's say Thursday, things start turning, and by next weekend, theoretically, we could be in a semi-legitimate surf pattern. That would be good news. Supposedly driven by the active phase of the MJO, though there is much debate on the MJO models about whether that's really going to happen or not, but we'll go with it for now. The long-term forecast suggesting more of the same, low-pressure bias building on the date line through the summer into the fall, and we suspect maybe a pretty healthy, not over the top, but at least a normal summer surf pattern, because all this stuff we've been talking about also affects the jet stream in the southern hemisphere as well. It's all interconnected. The globe is one living, breathing unit, and it all responds in kind. So our thought is summer, probably doing okay, a little bit above average. And then we get into fall next year, maybe even a bit above that. Too early to know. We're in the spring unpredictability barrier from, March through about the end of May. The models have a real hard time getting a handle on what's going on. So who cares about the models? We watch Kelvin waves and westerly wind bursts, and that really tells the story. And, if that keeps up, we're in good shape. But if the jet stream starts falling apart and splitting and Kelvin waves don't happen and blah, 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 then it's a bunch of hype by the models. But for now, we're cautiously optimistic. The short term, a little bit of a dry out for California, but we suspect another round of precip, late season precip, as the active phase builds in the West Pacific. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.